We spoke about scaling, how to scale, how to use a scale, when to use a scale, and um, how to write. Over here, you see how to write the scale that you're using. You usually put this on your graph paper, somewhere up the top, the scale that you're using. And we said that there really is just two rules when you are doing scaling. One is that your scale must be consistent for the entire axis. So if you're using a particular scale for the y-axis, you use it for the entire y-axis and not just the positive portion or the negative portion of the y-axis. So if you're using a scale, it must be consistent for the entire axis. And the whole point of changing up the scale is so that you can accommodate the points that you would have gotten when you did your little table, and we did an example of that a little bit later. So and also you can have a different scale on both of the axes. So you can have a scale on your x-axis, and you can have one scale on the x-axis. Say you have 3 units to 1 centimeter on your x-axis. You can have a completely different scale on your y-axis, depending on what is called for in terms of the points that you have to plot. The whole aim is to get all of those points to hold on the Cartesian plane that you drew. And so you scale your axes to accommodate those. All right. And then we went ahead and we looked at how we can plot a function on a Cartesian plane. I'm just going over what we did last week. We went ahead and looked at how we can plot a function on a Cartesian plane. So we said, so this question said the function f of x equals 5 plus x, and it gave the range of values for x -3 to greater equal to or less than -3 and equal to and less than +3, sorry. And I don't think this is the right sign, but yeah. And so what we did, we had all of our x values, we just put them in a table here, and then we plug each of the values individually into the function, and got a corresponding y value. And we did that for all 7 of these x values. So we had 7 calculations here. And then for each pair, we went ahead and we plotted it on a graph just to give you an example, an idea of what that looks like, right? And then you got this now homework where you were to go ahead and draw the function table, well, calculate, well, plot the graph for this. And by plotting it, you need to calculate the function for the different, for the ranges, etc., etc. So everybody did these 5 graphs, because you're not going to be able to function in the class without it today. So do you all have your graphs ready to go? Nobody did the graphs? Because if you don't do the graph, we're wasting time today. We don't really have nothing to do if you don't do the graph. Ladies and gentlefolk, where are we today? Did the graph, don't do the graph, you have to tell me so that we know where we are. Because if you don't do the graph, we are not in a good place. All right. So the equation of a line is y equals to mx plus c. And each of the items in this formula has a specific, I don't know if you want to call them role or function. So what we're going to do, I'm going to use question 1, which is 5 plus x, the function 5 plus x. Don't know if you remember the one that we worked out together in class. I'm going to be using this table and this graph as our example, all right? So just follow me. I'm just going to be copying the table back here. I'm going to run out of space. 0, 1, 2, just for the benefit of us understanding y equals mx plus c. I think we got 2, 3, 4, 5, 6, 7, 8. Jonathan, can you double check to make sure that this is correct for me? That what I have in my table is correct? All right. We drew a
graph.
Sorry, we drew a graph for that, but I'm not going to draw the graph right now for you to see. So this y here is actually any one of these y values that we have in the table. It can be any one of them, right? And it could be any y value of the graph, because remember we had said we had restricted our x values to -3 and +3, but we could do -10 to 3, -10 to +20. Understand? We could make the graph as long as possible as we want. So really, this y value here represents any of the y values that you get when you plug in one of the x into the function, all right? This x value is also any one of these x values up here, or it could be any x value at all. Because remember, again, this is just our restriction for drawing the graph, -3 to +3, but it could have been -50 to, you understand, any other number. This x value comes from up in this table just the same. So the point I want to make is that this y and this x value that is in the equation of the line comes from when you plug values in the function. Everybody clear on that? The other thing I want you to note about this y and x value is that when you are using them, it must be from the same pair, right? So if you're using your y and your x value, you can't, if you plug into this formula right here, you can't use this y. So you're using y to be 4, and you're using x to be -3. You can't. You have to use, if you're using y to be 4, you have to use a corresponding x value, all right? Because remember, what each of these pairs represent is a point, right? And so if you use the negative, if you use the +4, for example, for your y value, that means you're using the y value for 1 point. And then if you use -3 for your x value, you'll be using the x value for a different point, which will not work out. So you have to use the pair, the coordinate pair when you're working out this formula, right? So you use the corresponding y and x values together. Clear so far? M now is our gradient. And we're going to work out gradients for all of our graphs today. So M is a gradient, and then C is what we call our y intercept. All right? So C is our y intercept. So I'm going to go ahead and for this, what do you call this now? For this graph, for this function, I'm going to show you how you can get M, which is a gradient, and C without, which is the y-intercept, without using the graph at all. Just by having the function, I'm going to show you how to get it without using the graph, and then I'm going to show you how to find it using the graph, right? And the reason for that is you need to know both ways, because you really don't know how your questions will come, right? I've seen plenty of questions for these type of things that don't come with a graph at all right? So we're going to practice both ways. So I'm just going to small this up, and then we can go ahead now. All right, so let's talk about our gradient first. Now, gradient is really is a measure of the slant of your line, right? So when you plot this graph, for example, it looks like this, right? It's slanted to that way. All right, so let me give you it on a, let me just use this. All right, so when we plotted our graph here, this is the same one, the 5 plus x. This is the same 5 plus x function graph, right? That we plotted here. So when you plotted this graph, we see it slant this way, right? However, if I'm supposed to plot, let me see if I can plot 5 minus x, you will see it slant the opposite way. Are you seeing that? Everybody seeing that? Come on, you have to answer me so I know, you know. All right, so I'm just going to assume that you know, that you're hearing and you're understanding. All right, so if I plot the function 5 minus x, as I've just done, the graph slants the opposite direction, right? So that's one thing. Your graph can slant either that way, which is, I don't even know how to call it, what to call it, but you're seeing it. It can slant like that, or it can slant, I use a +5, which is what you have. Or it can slant in that direction. All right. Other thing is the slant can be different. So I just change it to 2 plus x, and you see it slant a little differently. And if you should go through all of your the graphs that you drew just now and you compare the slant, you can see that the slant can be very different. You can have one that slant like that, one that slant less, one that slant like that. The slant can be different. And so the gradient that you get, the answer that you get when you measure your gradient is really a measure of the slant, right? So that's all gradient is. Now, if you are measuring your gradient from your graph, you would use what we call rise over run. And have you ever heard about that one before? Rise over run. If you've done math before, I suspect you would have heard about it before. So rise over run. But we use this one, we're going to use this one, the rise over run, when we're finding the gradient using the graphs, right? But since we're going to find the gradient and the intercept without the graph right now, with just the function, we're not going to use rise over run. We're going to use the expounded version of rise over run, which is y2 minus y1 all over x2 minus x1. So this is the formula for gradient that we are going to use. Now again, y2 and x2 represent corresponding points. So if these are for the same point, just the same like I was explaining right here, you can't use 4 and then 3 over here. So you have to use, you know, the same point, right? So this is for corresponding points, and it's the same for y1 and x1. y2 tends to be the larger one. So y2, you pick your y2 from somewhere down this end, and y1 would come from down this end, right? So y2 would be the bigger of the numbers, y2 and x2, and you'll see why when we look at it on the graph. All right. So if I am going to, let me just clean up this for a while. So I'm going to now calculate my gradient using the table here. So I'm going to choose a random pair, right? So all I need is 2 pairs, one that represents y2 and one that represents x2. So I'm just going to write it up top. I'm write it on the bottom because I don't have enough space. So all I'm going to do is just to just randomly choose. There is no science to it. I'm just randomly choosing. So I'm choosing this one from a 2 function, and this one from a 1, right? So then that means 7 would be y2, and x would be, x2 would be y1, and then 2 would be my x2, 2 would be my y1, and this would be my x1 values. Are everybody seeing that? Tell me that you understand what I'm doing. So I'm choosing these two pairs of numbers to plot. So this would be my y2 and x2 pair. This would be my y1 and x1 pair. So let's work it out. So y2 I have equals to 7, and y1 would be 2, so it's minus y1, which is positive 2, and it's all over x2, which would be 2, so I get that 2 from up here, minus x1, which is negative 3, so I have to put that negative 3 there. I can put it in a bracket, and that would be equal to 7 minus 2 gives me 5. 2 minus 5, this comes together to give you a plus, so that's 2 plus 3 gives you 5, and then your gradient is a positive 1. Everybody follow? Gradient is a positive 1. So that is using that pair. But I chose those numbers randomly. What if I chose a different set of numbers? What if I decided that, because again, when you're doing your exam, you're all in your own seats, right? Doing your own thing. So what if Allison chose to use that pair as her X and Y, and Amoy chose to use a different pair. So Amoy chose to use this pair and this pair right here. So these will be the 2s, these will be the 1s. So that the y2 in this case would be 8 minus y1, which would be 5, right? So this is y2, this is y1, and then x2 would be 3 minus x1, which should be 0, equals to 8 minus 5 gives you 3. 3 minus 0 gives you 3. Yes. Yes.
Isn't your y1 3?
Let me check that. y1 3?
Yes.
No, so all the y's are in the bottom
5.
row.
Sorry, I'm sorry.
Yeah.
Yes,
all the y's are in the bottom row, all 3. The x's are in the top row. Yeah, 3. So 3 over 3 gives me a positive 1. All right.
That means the gradient for all of it would be 1.
The gradient for the entire line is 1. It don't matter. And that's a point I was going to make by using these two random points, two different random points. Any 2 points you take from your line, once it's with the same function, any 2 points should give you the same gradient, because the entire line is slanted in that way. You understand? It's not like part slant up and part slant down. The whole line is slanted in a similar way, in the same way. So any pair that you take, you should get the very same gradient. So the gradient for the line is 1. So it don't matter which pair you take, right?
Okay.
That is clear. And I'm going to do one more for emphasis. I'm going to take a completely different one again, just to make the point driven home. Just to drive home that point, right? And remember, we're doing all of this using just the function itself and not the graph as yet. So let's do another one. Let's say I am Teresa and I am in my exam and I chose to use the 2 endpoints of my line, which is those 2, right? So in that case, 8 and 3 will be my two values, and these will be the 1's value. So y2 is 8 and y1 is 2. So I would have 8 minus 2 over x2 is 3 and x1 is minus 3. So that is 3 minus 3 gives me 8 minus 2 is 6. 3 minus 3 minus 3, which is plus 3. 3 plus 3 is 6. Answer is positive 1. Don't matter which points you use, the entire line is slanted the same way, you should get the same answer. If you don't, then your answer is wrong. right? Then you've done something wrong somewhere along the line. So are we all clear on that so far? How to find the gradient this way?
Yes, please.
All right. So I'm just going to put it aside that our gradient for this function is equal to +1. So the gradient, which is m in the formula, is equal to +1, right? So let's talk about C now. Remember our formula, remember our equation of a straight line is y equals to mx plus c. Now y and x we have because we have lots of what you call it now, y and x values here. We just worked out m, which is our gradient, and there is c, and we said c was our y-intercept. C effectively refers to, so let me just bring up back this. C refers to the y-intercept. Where along the y-axis did the line cut? So where did the line meet the y-axis? In our case, it is
5.
right. In our case, it is 5,
Would
right?
be
We
a
started to the 5. Well, I think it is, because I remember I drew that freehand, but I think it is 5 because there was an actual point.
Yeah.
So I think we got 5 for that. And even if, let me just, this is what, 5 plus x. That is it, 5 plus x. And even if we go back, we go here, the 5 plus x, we would see that it is 5 as well here. Let me just get it to be 1 to 1. This is our y-intercept. C cuts right at 5 here, but this is using the graph. But what if you don't have a graph in your question, which could very well be the case? If you don't have a graph in your question, you have to use the equation of the line to go about finding out any information, right? So let's assume you get the function. If you get the function, you can always figure out some points, and then you can go ahead and substitute and solve for C, for your y-intercept. So I'm going to just randomly again choose a pair. I'm going to choose this pair, -3, -2 and +3, to use in my equation of the line to find the y, to find the C, which is my y-intercept, right? So 3 is going to be my y value, and the -2 is going to be my x value. I found my m earlier to be 1, so I am going to be able to find C, all right? So let's do this now. This equation would work 3 equal m, which is 1, times x, which the corresponding x value is -2, plus C here, right? So they should have 3 equals to -2 plus C, and then 3, carrying over this, cross the equal sign here. So it's -2, so when it comes across, it becomes +2 equals to C, 5 equal to C. So that is how you find C without going on a graph. You have to use the equation of the line to find it. And again, I'm going to make a similar point that because it is the very same line that you're doing, it doesn't matter which y and x pair that you use. So I'm going to do the same thing using this one in blue. Y is 5 and x is 0. So that would give me 5 equals to gradient, which is 1, times 0 plus C. 5 equals 1 times 0 is 0, plus C. 5 equals to C, using a completely different pair. And for emphasis, I'm using another one, this one in red, where y is 8 and x is 3. So I would have my y value being 8 equal my gradient, which I found to be 1, multiplied by my x value, which is 3, plus c. 8 equals 1 times 3 is 3 plus c. 8 minus 3 equals to c. 5 equals to c. Everybody clear on that?
Yes, sir.
And that is without using your graph as yet, right? Now, what I want you to appreciate about this equation, I'm just going to use a different, clear, y equals to mx plus c. This equation is what we call equation of a straight line, right? And it doesn't matter what the function that you use to get the line, this equation works for it. This equation is how that line is defined, right? Can be used for all lines. However, there are just a few exceptions. If when you draw your line, it is parallel to any of the axes, this equation you don't use, all right? So if the line is not parallel to the axis, parallel meaning it line up straight with the axis. So you see like I have this one here, where it line up straight with the y-axis. You see that? The black line, this is my line. It lines up with the y-axis, straight with the y-axis. The equation of the line, don't use for that. This line, when you plot it, it line up straight. It is parallel to the x-axis. You can't use the equation of the straight line for that line. It's only if your line is not parallel to the x-axis, meaning it's slant in some way, right? And it's kind of obvious because if it's not parallel, then your gradient will be equal to it won't have a slant. Your gradient will be equal to 0, and then you can't use this formula anyhow, right? So in order to use this line, I'm just going to write it. In order to use this line, the line must not be parallel to the axis, to any of them, whether it's the x-axis or the y-axis. Otherwise, you can always use your lines. You can always use this formula, the equation of the straight line, to solve for y, or for m, or for x, or for c. And bear in mind that this is an equation, like a regular equation. So if you get everything else without, and you don't have m, you can always find m using this formula. You understand? You can always reshuffle this formula to find x or m or y or c, as the case may be. Are we okay so far?
Yes, sir.
All right, now, so I'm going to show you how to use I'm going to show you how to use the graph to do the things that we just did a while ago, which is gradient and y-intercept. The y-intercept I show you already, right? So if you look, this dark line here with the numbers is your y-intercept. It runs from top to bottom, and the one from left to right is your x-axis. So y-axis from top to bottom, x-axis from left to right. And we said that your y-intercept is the place where the line cuts the y-axis, and all you need to do is to look on your graph and just to find where the y-axis and your line meets, and in this case it is 5. All right, so that's how you would go about doing it. For the other one, I can't write on this. This isn't a document I can write on. to show you, but I'm just going to show you just sort of a rough way how you find the gradient of your line if it is on the graph, right? And usually, let me just say, usually whether I have a graph or not, I usually use the other method just because I think it's, you know, I don't know. So it's rise over run. So rise, so rise would be from top to bottom, which is, this is our rise right here, and run would be from left to right. So this is our run right here. So you would measure, you can use your ruler and measure how much centimeters it rises and how much centimeter run is, right? That is one way of doing it. So you use your ruler. The other way, you don't have to use your ruler because your graph paper is already measured for you. So remember we said from one of these dark lines to the other dark line is 1 centimeter. So you can literally just count it. So if you have your rise that goes from here to here, I'm so sorry I can't draw on it, but if you're seeing where my hand is running, if I chose this to be my rise from this point here all the way over to this point here, all I need to know is to count. One dark line to one dark line is 1 centimeter. So this would be, where am I? 1 centimeter, 2 centimeter, 3 centimeters. So that would be 3. And then my run now would go all the way up to the line. So it would be from right here where I started, 1 centimeter, 2 centimeter, 3 centimeters. It would be 3 over 3, which would give me the same 1 for my answer. All right. Any questions?
Let's go over that again.
All right. See, it's going to be what are you using, your phone or your laptop?
I'm using my laptop.
All right. So, all right. So let's look at. All right. So I'm saying for your when you're doing it on your graph paper, when you have your graph paper, you can still use the previous method that we did earlier, right? You can still go ahead and use x2 y2 minus y1 over x2 minus y2. What am I saying? Y2 minus y1 over x2 minus x1. However, on your graph, you measure it by saying rise over run. So what all you need to do is to draw a line draw a dotted line from your line that you've plotted, and then you connect it upwards to that same line, just a triangle like this, right? From top to bottom, from that little triangle that you draw, is what we call the rise. Because remember the formula for gradient is
Right over run.
Right. So remember we're trying to find the gradient. So the rise in this case is from top to bottom of that little triangle, rise, like you're rising up, right? Bottom to top. Yes. So you could use your ruler and measure this in centimeters to get the length of your rise. Follow me?
Yes.
So you could use your ruler to get the length of your rise, and then your run is measured from where the two lines meet, the edge, this corner of the triangle, to over where
on the negative axis of x.
Well, it don't have to be the negative axis of x. It just know that it is the run which is from left to right. Right, the run which is from left to right. So this portion, let me put it in a different color. So this here would be the rise. You would measure that with your ruler for your rise. And then from here to here, you would measure with your ruler to get the run, right? And it's just a simple centimeter value. Follow me?
Yes.
And just for argument's sake, you would get, so for example, you get 3 right here, so, and then you get for your rise, you get 6 right here, so for your run, you put 3 centimeter over 6 centimeter, and you cancel it out, and you get half, right? For argument's sake. And that's how you would get your gradient using this way, right? If I show you on the graph now, the challenge with the graph is that I can't write on the graph. This application doesn't allow me to write on it. So I'm going to have to explain it to you just visually, right? So we can draw an imaginary line. Say and this is for our actual graph. This is for the function y equals 5 plus x. So this is our actual graph. So we're going to draw our imaginary triangle from right here. So you see where I put in that?
Yes.
From right here, so, and I'm going to draw it to right here, so, yeah?
Okay.
That is my run. From right here, so, all the way over to right here, so. And then my rise will be from that same corner up to the line, right?
Okay.
Now I'm saying to you, if you have your ruler, you can still measure it. Use your ruler, measure it, and you will see what the rise and the run is. But if you don't have your ruler, remember that your graph paper is actually measured, right? Each of the dark lines, the boxes, the dark from one dark line to another dark line is 1 centimeter. So from this dark line here to this dark line is 1 centimeter. And then from here to here is 2 centimeter, yes? From this dark line to this dark line is 3 centimeters. And then from this one to this one is 4 centimeters, yeah? So it's the same measurement I would get if I use my ruler, but if you don't have your ruler, it's always important to remember that your graph paper is ruled. One of those big boxes, the darker lines on your graph paper measure 1 centimeter. So I would get 4 centimeter if I measure this, right? If I measure the run now, the rise, which is from this corner to where it meets the line, right here to right here is 1 centimeter. Here to here is 2 centimeter. Going up to here is 3 centimeter. And then up to here is 4 centimeter, which means that my rise would be 4, and to be 4 over 4, which is 1, which is the same answer we got when we worked it out using y2 minus y1 over x2 minus x1.
Yes.
Understand it now?
Yes, sir.
So I'm just showing you the different way. You can use your ruler, or you can actually, the graph paper is the rule that measured for you. But the basic principle is rise over run. Again, I drew my triangle like this, but if I opted to make my rise start from right here, so, and my triangle get a little bigger, I would just measure it, come my run all the way back here, and my rise all the way to this top here. So it's just the same thing, like saying it doesn't matter which 2 points you use, right? Just like when we were doing it on the table, and it didn't matter which 2 points we use. It doesn't matter where you start, you're measuring your run, and it doesn't matter where you end it either. Yeah, as long as the 2 points that you use are on the line. Clear?
Yes, sir.
The other thing I want to point out before we move on is that typically we draw our rise and run triangle. We draw it at the bottom like this, right? Because it makes life easier for us. It's how we see. It's how we see. Oh, it's how we visualize a triangle, and so it makes life easier for us to do it that way, right? But I just want to point out that it doesn't have to be. You can choose to draw your rise and run at the top of the line as well. So I'm just showing you this in case you get a question that do that. So your rise and run can also be at the top of the line. The rise and run triangle that you draw can be at the top, in which case, from top to bottom or bottom to top, this would be the rise. Your rise would be over here. And your run would still be from left to right. So this would be your run. And you would measure it just the same. Clear?
Yes, sir.
So no matter where you put your rise and run triangle, as long as it connects 2 points along the line, it could be on top of the line or it could be on the bottom of the line. All right, so we're good on gradient, finding the gradient without or with the graph, and finding the y-intercept, finding the y-intercept, which is C in our equation of the straight line, finding the y-intercept. So I'm going to give you 10 minutes now for you to go through and calculate both the y-intercepts and the gradients of the graphs that you've drawn so far, the 5 of them. So y-intercept and gradient. So I would suggest calculating your gradient first and then your y-intercept. If you choose to just use y2 minus y1 over x2 minus x1 to find your gradient, that is also fine. But I just want you to use one way to find them now in the interest of time so that we can move on. So just 10 minutes to go ahead and find all the gradients, the 5 gradients, and the 5 y-intercepts. All right?
Okay.
All right, so let's start again. So I'm just going to run through, Shauna, because you did the question just now. So I'm just going to run through and to double check whether or not your stuff that you have are correct. So I know that you started out. So we did question 1, which was the 5 plus x function. So let's look at the minus x minus 7. What did you get for your gradient for that one?
I got 1. After working it out, I got 1.
Positive 1, great. And then for your x-axis?
For my
for your x-axis?
I got 4, but it doesn't seem right.
You got for your x-axis, you got 4. So if you
right.
So how did you get that x-axis number? Did you look at the graph or did you just calculate it?
I tried to calculate it.
So do you have a
graph? My graph don't look so right. As I told you before, the graph don't look so perfect.
Is it a straight line?
I'll call it a straight line, but it doesn't really look like a straight line, to be honest.
Well,
I'm trying to plot them in order for them to look like a straight line.
No. Once you get the points on the thing, it should automatically give you a straight line. You use your ruler and they should all line up. They should all line up. So if they don't all line up, for these ones that we have here, if they don't all line up,
that's the problem. They don't line up.
You may have calculated something wrong somewhere, but they should all line up because they're all straight lines.
I'm going to go back over there.
All right. But just for information's sake though, when you do your minus x minus 7 graph, when you draw it, even though you say it's not perfect, where does it cut the y-axis?
It cuts the y-axis at graph paper. I have too many graph papers in front of me.
So you're gonna label them with the function. You should tell them last to put the function.
I didn't label them along.
What? I told you last to put the function on them when you draw them. So the one for minus x minus 7.
One for minus x minus 7 about minus 14. Yeah.
I want to know for that graph, where does it
14 is from minus 14, minus 13, minus 12.
Yes, that one. So I want to know what's your y-intercept? Where does the line cut your y-axis?
It's 7.
What kind of 7? Negative or positive?
Negative 7.
And that's correct. So negative 7 is correct. That's your x-axis. That's your y-intercept. Yeah, that's your y-intercept. So
I'm going to go over the rest.
Am I sharing my screen? Yes, no? Are you seeing my screen? You're seeing a graph with a lot of plots.
With a lot of lines.
Okay, great. So I wanted to just plot all of them on one graph. So the one that you're looking at now, the one that we're looking at minus x minus 7 is this big blue one right here. And it cuts the y-axis. If you see where it cuts the y-axis, you see that?
Yes, please.
Negative
Right,
7.
minus 7.
And I worked it out as well. And when I worked it out, I use the first point, which is negative 7 and negative 14. Negative 7 for my x value, negative 14 for my y value. And when I put those in the equation of the straight line, I did get the same negative 7. So your graph seems to be okay. It's just a matter of looking at where you went wrong as far as the calculations.
Yes. I'm going to rerun the others.
Okay, so that's the first one. For the other one, 4x minus 6, what did you get for your gradient?
My God. You want 1 also. I'm not too sure.
I didn't get 1, but let me just work it back and see. What did you get for your x-axis, for your y-intercept in the meantime?
Minus 6, minus 2.
No, y-intercept.
Hold on.
The intercept, so when I ask for the y-intercept, I'm asking for where the line, the C value, where the line cuts
for the C value.
Yes, so that's what is called the y-intercept.
Because I didn't finish calculating that part.
Look on your graph and tell me.
2.
So you got 2, positive 2, negative 2? 2. All right, so let me check it and see. So what I got here, this one that you're looking at, the purple one. That is it, and it seems to be a negative number, negative 6. I didn't calculate that one, so let me just run through and calculate it. So let's confirm the gradient first, because you and I have 2 different numbers for gradient. I have 4, so let me just double check to see which is right. I'm going to use 2 different points right now. What were your y values that you said you got? Minus 6, minus 2?
Yes, 2, 6, and 10.
Okay, great. So just recalculate your gradient and let's see who went wrong. Oh, I think I know where I went wrong, but calculate just the same. Minus 2. And get back the same answer. I'm getting 4 for my gradient. Huh?
Going where I went wrong. It's all have to rework those. And the other 2 that it was. I definitely have to rework those. So for the last 3, I'm going to rework them.
Okay. 6 minus 2 is 4. Over 3 minus 3 is 1. So I'm getting 4 for my gradient for this one, which is 4x minus 6. I'm getting 4 for my gradient. So
yeah,
call mx plus c. So if I use 10 plus 4 times 4 plus that, 10 equals to 16 plus c. 10 minus 60, yeah, negative 6. So it's correct. So on the graph, I'm getting the y-intercept to be negative 6. And when I calculate it, it's negative 6. So the gradient for this one is 4. So I was correct. The gradient for this one is 4. And the y-intercept is where the line cuts the graph. That's negative 6. I'm going to run through all of them just to see what you have and so you can know where you went wrong. The fourth one, 2 minus 2x, which is this one. So that's that black one now.
Minus
that
2.
One that you say. So what did you get for your y-intercept, where the line cut the y-axis? What did you get for that?
I got that at 4. No. It's just I said, looking at it now, I think where I went wrong.
Okay. So the gradient for this, seems to be, but I'm going to have to give you a couple minutes to rework them because we're going to need, well, not necessarily. Let's see. And the gradient for this, probably not as, I have to go back a little. So the y-intercept for this one is right here, which is 2. You see that is where the line cuts the y-axis.
Yes.
So this is 2 right here. And I need to go back even more. I'm trying to find an easy way to find a gradient, but I'm not seeing anything lining up. But I did work out my gradient and I got, I think I got something wrong here. I get 6/3, which was 2, but we can double check that one. For number 5, the last one, which was -2 plus 2x, which is this one. That's a red line now that you're looking at. So if we can see where the line cuts the y-axis.
Looks like 1.
Cuts the y-axis. -2. Let me big it up a little for you. Just see there? -2. So it cuts it at -2 right here.
I cut it at 1 on the x.
Yeah, but the x, the cut for the x-axis, not critical for the equation of the line. So this would be -2 would be our c value. And then if you work out the gradient, we should get 2, +2. Okay. So in that regard, you'll be able to work out you'll be able to have all the values for the equation of the line that you need. So, and those are parameters that are important for you to learn how to work and important for you to know what they mean, all right? Also important is for you to appreciate that your gradient can also be a negative number. So if you work out your gradient and it turns out to be a negative number, don't panic. Your gradient can be a negative number. It just speaks to the direction in which it is slanted, right? So some slant, from left to right, some slant from right to left. That's all that it speaks to. So you can get a negative number for your gradient, all right? So let's move on to another thing that we need to learn about these things, and this is for the function f of x equals to 5 plus x, all right? So another thing that we are going to be looking at now is the length of the line. And these are just formulae. And I'm going to give you some time to, probably I should write it down here. I'm going to give you some time to work out these as well for your graphs that you have. And these are just for practice purposes. So the length of a line is, and some books will call it distance. It's the same thing. It's a difference of y coordinates squared plus the difference of the x coordinates squared. So if you were to simplify that, it would be the root of y2 minus y1, and don't forget the squared at the top, plus x2 minus x1 squared. So this is how you would find the length of your line, right? Or the distance of your line. The distance between 2 points. That is what we're finding. So if you notice, you have you have a pair. What you have underneath the square root sign is effectively two points. So y2 and x2 would be the coordinates for 1 point, and y1 and x1 would be the coordinate for another point, or another point. So if you have a line, for argument's sake, and you get this point and that point, this would have a x1 point and a y1, and this would have a x2 and a y2 points, yeah? And you can also find the distance between two different points. You understand? So that's what you're finding when you're using this. This is literally the distance between 2 points. And if you notice, it sort of should remind you of a right angle triangle. And when you're finding distance of a right angle triangle, and this is just some background information now, just to show you that we're not picking these formulae out of a hat. When you did your right angled triangle Pythagoras theorem to find the lengths of the sides, you said the hypotenuse, which in our case would be the length of the line, right? If you look at this triangle, the hypotenuse would be like the length of your line. I'm going to call that AB. So your hypotenuse, which is the AB, which is the distance that you're trying to find, will be equal to 1 of this length squared, right? So this you can call this the rise. So you can say the rise squared plus the run squared, right? This look like the Pythagoras theorem, right?
Yes.
C, right, which is C squared equals A squared plus B squared. And in this case, you're trying to find, if you're going to find that, you're going to have to root both sides to get rid of that square sign and to get rid of the square sign here, because that is squared. So AB would equal to the root of the rise squared plus the run squared. So this is just a background as to why this is a formula to find length of the line. It's literally using Pythagoras theorem that you learned some time ago, right? Not too long ago. And this is rise and run. This is why this looks like what you have on the top of your gradient formula. And this looks like what you have on the bottom of your gradient formula, because this is rise over run. All right, that's just some background to this formula. So the formula that you would use is the root of y2 minus y1 squared plus x2 minus x1 squared, right? So I'm just going to do an example so that you can understand where we are coming from. So the reason why I explained to you how this formula was derived is because you're going to meet upon a lot of formulae, right? And quite often, understanding is better than swatting, right? And by saying quite often, I'm being modest. It's usually all the time. Understanding a thing is better. So when you go in an exam, if you don't really remember the formula where you swat, you can reason your way through it literally by doing this, with the rise, we're going to run and taking this as a triangle itself, a right angle triangle, and working it out mentally. And it will help jog your memory and help bring you back to what the formula is, right? You can't always rely on swatting because, trust me, swatting doesn't always help. So let's go. Let's find the distance. I'm going to just use 2 arbitrary points here just to show you how the formula works. So let's find the distance between this point here and this point here, right? So the one over here, this is your 2's and this is your 1's, right? So y2 is 6, x2 is 1. Y1 is 2, x2 is -3. So let's go. Putting everything on just use a different color. You're putting everything underneath the square root sign, and you have y2, which is 6, minus y1, which is 2, that is squared, plus x2, which is this one here, minus x1, which is -3, so that's -3 squared. And I'm just going to, 6 minus 2 is 4 squared, plus 1 plus 3 is 4 squared. And that, of course, is equal to 4 squared, and 4 squared is 16. 4 squared is 16. So 16 and 16 is 32. And then the root of 32, you just punch that into your calculator.
5.656.
All right, so the root of 32, so I don't need the root sign anymore. The root of 32 is, you say, 5 point how much? 5.65 or 5.66.
Yes.
All right, so units. So that would be the
length of the line.
the distance, yeah. Distance between these 2 points, which is this and this, right? The 2 points that you calculated. All right, it's not the length of the line in infinity, because the line can go on and on and on and on and on, depending on the values that you plug into it, right? But this formula literally gives you 2 boundaries. It gives you an x, 2 points as a boundary, and then you ought to find the distance between them. The thing about this is, all right, so let me just make a point before I explain further. I'm just going to delete all of this under here to work another one. So what I'm going to do is quite like when we worked our quite like when we worked our gradients and such not too long ago. I'm going to use 2 different points, right? So I'm going to use these points over here. So that will be my 2's. And I'm going to use this point over here, right? So now it's 2 different points, but they're on the same line, right? So let's work it out. So my y2 would be 8. So I'm under the square root of 8, y1 is 3, minus 3 all squared, plus 3 minus 2 all squared. That's going to give me 8 minus 3 is 5. 5 squared. So let me just write it. I don't want to shortcut it. And 3, what you call this now? 3 plus 2 is 5. So this is going to give me 25 plus 25 equals to 50. The root of 50 is
7.07.
7.07. Now, the point I'm trying to make here is that the answer you're going to get is not the same, right? And that's okay. The answers you're going to get is not going to be the same, like when we work out the y-intercept or the x or the gradient using the equation of a line. It's not the same because the distance from here, between here and here, right? The distance between here and here is not going to be the same as the distance from here to here. You understand me? It's going to be a different distance. You get what I'm saying? And so this is what this formula measures. It measures the length of the line between the 2 points that you are given or that you have, right? That's what it measures. It doesn't measure the length of the line itself, like the line in general, right? Because effectively the line can go on and on and on forever, in infinity, depending on the values that you plug in, the x values that you plug in, right? So what this formula gives you is the length of the line between the 2 points, or you can call it the distance between 2 points, right? So if you choose to prefer, which is what I prefer to use, is to say the distance between 2 points. That's what I like to call it, the distance between 2 points on a line. That's what I like to call it, all right? So are we clear about that? And the unit for this is units. Any question? Any questions? All right, so let's go again. We're going to be doing a different, another property, another calculation now we're going to do. We're working our way through all of them. So please bear with me. They're all things that we need to do, and then we can start working some questions to pull everything together now. All right, so let's go now. So what we're going to be finding now is what we call the coordinates of a midpoint. So we're finding the midpoint of a line, right? All right. Now it's important for you to appreciate that when you get an answer for your midpoint, it's going to be a coordinate because it's literally a point on a line. And remember, we had established that a point on a line is represented, sorry, is represented by an X value, an X location, and a Y location. All right. So let's say we have this line. Why is it? Let's say this is our line. As before, it is going to be the midpoint that of a particular boundary. It's not going to be just the entire line, because as I said, the entire line can go on and on. So let us say we have this
So would it be halfway between?
Huh?
Would it be halfway between the two main points?
It will be halfway between whatever 2 points that you are getting. So that is the midpoint. And so I want to make 2 points. The first being that the midpoint is between 2 given points, right? It's not between the entire line, because as I have said, the line can go on into infinity based on the X values that you plug into the function, right? So it's usually between 2 points, and those points have to be defined. They have to be given in some way, or you will have to extract it from the question in some way. And it's going to be the midpoint, literally is halfway between. And when you get your answer, it's going to be a coordinate. And it's very simple to find, right? It's the same like when you say it's halfway between, it's literally halfway between. So let's say I'm using these same 2 points, and I want to find the midpoint between the 2 points that are highlighted in yellow here. So what I need to do, the formula is going to be literally just finding halfway. So let's put down the two coordinates here. So we have 2 coordinates. So I'm going to call this point A and point B, because it's a midpoint between point A and point B. So I'm going to say point A is, so A is, the X value comes first, so that's -2, bracket 3, positive 3. And then, so this is A, and then B now is X value comes first, so that's 3, 8. So the midpoint of this is going to be -2 plus 3 over 2. So you add the A, right? You add the X and the Y value. No, you add all the X's and all the Y's. Sorry. So I'm telling no foolishness. Where's mine? So that's why I wrote out this initially. So you can see what is what. So this is A and that is B, right? So I'm going to just highlight the X values. So the X values are the ones that come first, and the Y values are second when we write the coordinates. So this would be our Y values. So we're going to add our X values and divide them by 2. So you have -2 plus 3, you divide them by 2, put a comma in the middle, because remember it's a coordinate you're going to get, and then you add your y values, which is 3 plus 8, and you divide those by 2, because you're finding halfway between your y's and halfway between your x's. So this would give you minus 2 plus 3 gives you positive 1. So this is 1 over 2, bracket 3 plus 8, that's what, 11 over 2. So this is a half, can't go any further. So this is 0.5, and then this would be 5.5. So that would be 5.5. So this now would be the midpoint.
Okay.
This would be the coordinates for your midpoint. So going back to the same colors, so this 5.5 would be your y coordinate, and then this one here would be your x. Because remember, these were your x's before you divide it by 2, and you got a half. Yeah, you got 1 over 2. And then this was your and then this was your y that you divided by 2, and you got 11 over 2. So it carries now that 0.5 is going to be your x value for your coordinate. So this would be the x value for your coordinate, and 5.5 would be the y value for your coordinates. So what I'm going to do, I'm just going to pull up the graph. So I'm just going to get rid of all of these. I just put them on it I just leave that one. That's the one that we're using for our example. So we found the midpoint between the 8 and the 3 and the 3 and the 8 and the negative 2 and 3. We found that midpoint between those 2 points was 0.5 and 5.5. So that's 0.5 on the x-axis and 5.5 on the y-axis. So we can go ahead and find that. So it was 0.5 on the x-axis. All right. So 0.5 on the x-axis. So not kind of too big here for all the way up. So this is 0.5 on the x-axis and 5.5. So I'm just going to go up, following the 0.5 line and go 5.5. So that's 5. 5.5 is somewhere off here. So it would be somewhere here. 5.5 on the y-axis. So you would, and that's basically how you would find it. And though that would be literally the coordinates are halfway between those 2 points. Any questions?
Let's work on another one.
All right, no problem. So let me just delete this. So I'm going to still call the points A and B. I'm just going to change where A and B are now, right? And again, the midpoint, the coordinates on the midpoint is good. You know what? I'm not going to change it. I'm going to change it. The coordinates on the midpoint is going to be different, right? And we're going to see why. Let's say I use this. I'm finding the midpoint between that point and that point, right? So this was A and that was B. That was 3 point. Is the same B we use? I don't remember.
Same B.
The same B, all right. But the same A.
No,
but B will be different.
B will be different.
Yeah, B will be different. So B is right here, right? For argument's sake, I'm just arbitrarily drawing it. So you can clearly see that the difference between this A and B, which we just found now, probably I shouldn't have used those colors. It's very misleading. We can clearly see that the difference between this A and B that we found before is going to be different than that A and this newbie, halfway between the blues, right, is going to be different than halfway between the pink and this blue here. Yes, yeah, appreciating that?
Yes, miss.
So the midpoint is not going to be the same for every point on the line, because the midpoint is bounded. It's defined. It's defined by 2 points, and so the midpoint is going to be dependent on where those 2 points sit on the line, right? So you're not going to have. So it's almost like saying if you're lining up in a line, oops, and these are all of us. How much of us are the class? Stephen, Shauna, Alison, Amoy, and Teresa. All of us are in the line right here, so right? We're lining up in the cafeteria to get our lunch. The distance between Teresa, which is right here, and Amoy, which is right here, is different. And so halfway between that when we're right here, so yes? But if I'm measuring from Teresa now, but all the way back to, say, Stephen, which going all the way down to right here, the distance is different. So the midpoint is going to be also different, yes? If I'm measuring from Amoy, go down to Shauna, which is right here to right here, the midpoint is going to be different because the distance is different. Everybody following me? So I want to get the picture that unlike when we did the gradient, and the gradient is always the same depending on whatever point you use, it's not the same with your midpoint and your distance between 2 points. Why? Because those are actual lengths. Those are actual, well, the first one, the distance is an actual length, right? Between 2 specific points, like what you're measuring between Teresa and Alison in a line, or Teresa or Shauna Amoy in a line. And the distance is halfway between those two, between 2 defined or given points, just like how you say, what is halfway between Shauna and Amoy in this line? That is going to be different from halfway between, Stephen and Alison in the same line. Following?
Okay.
So you're not going to get the same answer, and that is okay, right? I want you to be able to appreciate the concept for the concept's sake, and not necessarily, just swatting it. Yeah, swatting it alone don't make no sense, because when you come up on questions that you have to reason, your understanding is going to be very important. So I'm just going to write a formula. You have x2 plus x1, no matter if it's x1 plus x2 over 2, comma, y2 plus y1 over 2. So that is your formula for the coordinates of the midpoint of a line. So once you get the two coordinates, right, the 2 points that you're going to be measuring the midpoint of, you then go ahead and find the x's and the y. So the x's here is 2 and -3. No matter which one you put first. 2 plus -3 over 2. And then the y's are 7 and 2. So you have 7 plus 2 over 2 equals to 2 and -3 is -1. So -1 over 2. And then that's the x coordinate. And then the y coordinate is 9 over 2. All right. And then this is going to be, the x coordinate is going to be negative
-0.5.
Right. And that is going to be +1. So this is the coordinate.
Yeah, I have 9 over 9.
9 over 2.
Actually,
9 over 2, not 9 over 9.
Yeah. Thank you very much. Thank
4.5.
you. All right. .5. So this would be your x coordinate, and that would be your y coordinate. Clear to you?
Okay.
All right. So when Alisa don't respond, we just assume that the answer is yes to what I am asking.
Yeah, sorry. Sorry, yes.
Just assume that it is yes, since you're not talking. All right. But at least I know you're following. Huh?
I'm moving up and down.
Man, that's okay. As long as you're following.
Okay.
All right. So we've done quite a few things. So we've done quite a few things so far. Sorry. So for today, so far, I'm just itemizing for my purposes. So we've done the gradients, right? Which on the equation of the line is referred to as M. We've done the y-intercept, which in the equation of the line is C. So I'm just going to write the equation of the line, which is y equals to mx plus c. We've also done the distance between 2 points. On a line. And we did just know midpoint, coordinates of a midpoint. All right, so you have worked out gradient already. So I gave you time to work out gradient for your graphs and your y-intercepts. I'm going to have you choose just 2 random points on all of your graphs and work out the distance between those 2 points and the coordinates of the midpoint. This is purely practice for, you know, getting yesterday, flexing those muscles to get familiar with the formula and with the concept. I'm going to just give you 10 minutes to do that. And then when we come back, we're going to be working some actual questions now where we're incorporating these concepts in them, all right? So 10 minutes to work these things out, and then we will be back. All right, so having gone through all of the previous stuff that I had mentioned, can't find my cursor, right? The gradients, the intercept, finding the distance between 2 points on a line, and the coordinates of the midpoints on a line, of between 2 points on a line. We're going to now work some questions, you know, more the type of what you probably would see in an assessment situation. So let's start with this first one here. So this question says, find the equation of the line through which the point, and they give you one single point, 1 and 5, through which it passes, right? So importantly, you know, what I want you to understand is that you don't have to get, just like when we had the table with lots of points, you don't have to get that, right? And when they ask you to find the equation of a line, all they're asking you is to find is M and to find C. And then when you find it, you write out the equation of a line as y equal whatever you get for M, X plus whatever you get for C. Because in truth and in fact, the C and the M will not change, but the Y and the X can change depending on what you put into the formula, right? So usually that's how you, when they say find the equation of a line, that's how you give it to them, right? So let's go ahead and see how we can work out this now. So we are given just one single point. If we are only given 1 point, we can't find the gradient. You need at least 2 points to find the gradient, right? We're given 1, but we're given 1 point and we're given the gradient. So we have the gradient, which is 2. So since we have the gradient, which is 2, we can then go ahead and work out what C is, because we also have one of the points. We also have an X value here. Let me just drop it in. Based on this point, this is our y value, and that's our x value. Do we all agree?
Yes, miss. Because the X comes first.
All right, great. So this is how we're going to do it now. They're asking us to find the equation of a line. The only thing we don't have is our c value. So if we just, you know, or we have our x value, we have our y, this is our slope, 2 is our slope, or slope is our gradient, which is m. So let's just write out the formula. Y equals to mx plus c. Only thing we don't have is c. So let's substitute all of these values in the formula, and then let us see what we get. Y is 5, m is 2, x is 1, plus c. So we have 5 equals to 2 times 1 is 2, plus c. 5 minus 2
Minus, so
is
C is
equal to c. So therefore, c is equals to 3. So we now have everything we need to write the equation of our line, like our question asked us, right? So we have a c, which is 3, and we have m here, which is 2. So we can go ahead and write the equation of our line. Y is equals to 2x plus 3. So that is how you write your answer. When they ask you for the equation of a line, that's how you write it. And the reason you write it this way is, even though you get 1 and 5 as just 1 point on the line, where in this case, you know, your y is 5 and your x is 1. If you recall, when we draw, when we do it like this, you have lots of different x's and y's, and any of them you put in the equation, you get the same answers, right? For x, for m, and for c. And so you don't usually put a value for y and a value for x. This is what the equation of the line is. So what this is saying is, whatever value you put for x, that what this point here for y and for x, this is, you know, the gradient is always going to be 2, and the y-intercept is always going to be c. So this is how you would write your answer. This is the equation of the line. Y equals to 2x plus 3. Clear?
Yes, miss.
All right, so if you have any questions or anything, just let me know, all right? So I'm just working a few different types of questions to show you, you know, how you can use the information that we went through and learned this morning in questions presented in a different way. This one says, find the equation of a line passing through the points 2, 7, and -4, 5. So effectively, what they're saying is that you have a line. They don't tell you what the function of the line is. They just say, all right, you have a line, it passes through a point here, which is 2, 7, and it passes through a point, what is 2, 7? 2, 7 is over here, so I think, yeah, +2, positive y, positive x. And it also passes through -5, -4, which is somewhere down here. So you don't know the equation for the line, but you know 2 points in the line. You know that it is bound by these 2 points. And forgive my line how it looks, right? So, and that's enough information for you to know, right? Because if you know 2 points in the line, you can find everything that you need. So you're being asked for the equation of the line. The equation of the line, I'm just going to write it just for emphasis every time. Y equals to mx plus c. And the portions in this that you need to give your answer, you need to find m and you need to find c, right? Neither of which you get in the question. However, because you have 2 points, you can easily go ahead and you can easily go ahead and find your gradient, because you have 2 points and that's all you need to find your gradient. So Remember that your gradient is y2 minus y1 over x2 minus x1. And just looking at these 2 points, these 2 points here, you can just say, let me just pick a different color. This is a x, so you can say this is x1 and y1. This is x2 and y2. Everybody following me so far?
Yes, miss.
So we have 2 points, right? So let's go ahead and just plug those values into the formula. y2, negative 5, minus y1, which is 7, all over x2, which is negative 4, minus x1, which is positive 2. That will give us negative, what's this? Negative 12, all over negative 6, right? And that will give us negative 12, negative 6, that's look like positive 2. Yes? Positive 2. So that's our gradient. You just found your gradient by using these two points that you got in the question. So you found this. The next thing you need to find out is the C. If you have your gradient and you have 2 points, you have more than enough information to find your y-intercept. So all you need is one set of points because you need a y value and an x value. So I'm going to decide to use these values here for my point. And I'm just being fun because they're negative. You could have used this one anyways, right? Should give you the same answer. I just want to be a little, I guess. All right. So to find our y-intercept, I'm going to use the equation of the line. Y equals to mx plus c. So I'm using my y from this, which is minus 5. And my m is my gradient that I just found, which is 2. X come from the coordinate, which is negative 4. C is what I'm trying to find, yes? So negative 5 equals to 2 times negative 4 is negative 8 plus C minus 5, and we carry this over the equal sign here, it becomes positive 8 equals C minus 5 and positive 8 gives you 3 equals to C. So you have your answer there, you have your C and you have your M. Let me just highlight them. You have your M here and you have your C there. So you can now write your equation of your line. I'm putting it in red up here. So you put y equals to your M is 2x plus your C is 3. So this here would be your answer. Questions? All right. I'm just going to, for the benefit of anybody else who decided, you know, again, when you're in your exam, you don't necessarily know what somebody else is doing until you come out and talk, and then you start feel insecure about your work because you hear say somebody do something different. So let us say this is me in my exam and I opted to use -4 and -5 as my values to plug in. And somebody else decided that they're going to use the other one, right? So I'm just going to just use the other one just to show you this one, just to show you that you get the same answer. So let's go. I'll get my y value from here, which is 7. So 7 is equal to m, which is 2. We found that 2 here. X from this would be 2 plus c. 7 equals to 2 times 2 is 4 plus c. 7, I will carry over this 4 across the equal sign. It becomes -4 equals c. 3 equals c, which is the same. answer. All right?
Okay.
Any questions for this one? All right, so we can move on to our next question. Again, and I deliberately did it this way where none of these questions asked you to draw a graph, right? And there may very well be questions that you're asked to draw the graph and do it, but you find these questions a lot sometimes, especially in multiple choice. And I just like having you do it this way just for you to practice and for you to just grasp the concepts more from a calculative type of perspective, all right? So there's no special reason why I'm not giving you any graph ones to do. Those will come in due course. All right. A straight line passes through the points P, and they give you the coordinates of P, and Q, give you the coordinates for Q. So I like to draw just to show you. So this is like you have a coordinate and you have a line. They don't tell you the equation for the line, but it says it passes through P, 2 points P and Q. All right, that's all it is. P and Q could be closer like that, or it could be farther. Just know that this line passes through 2 points, 2 random arbitrary points, P and Q. So given that they give you the coordinates of P and for Q, what are the coordinates for the midpoint of PQ? So the formula for your midpoint is going to be, sorry, x1 plus x2 over 2, and then y1 plus y2 over 2. Doesn't matter if you put the x2 first or the y2 first, because it's adding, so you're going to get the same answer. So it doesn't matter which one you put first, all right? So let me just identify what they are. So this here, let's call this x1, and this is y1. Call this x2, because it's our second point, and call this y2. So we have all our values, all our information there. So the x's are 1 and 5. So you have 1 plus 5 over 2. And then you have negative, well, 2, whichever way, plus negative 14 over 2. So we need to work that out. 5 plus 1 is 6 over 2. And then negative 14 plus 2 is negative 12 over 2. Both of these can be broken down further. So 6 over 2 is 3. And negative 12 over 2 gives you negative 6. So that would be the coordinates for our midpoint. Everyone following?
Yes, please.
Questions? Second, questions?
No, me, not yet.
Okay. Second part of the question now asks you to find the gradient of PQ. And we know the gradient is equal to y2 minus y1 over x2 minus x1, right? And we've identified y2s and y1. So this is negative 14 minus 2 over x2, which is here 5, minus x1, which is 1. Negative 14 minus 2 gives you negative 16 over 5 minus 1 is 4. And this can be canceled. 4 into negative 16 is going to go 4 times negative 4. So that is the gradient of P of the line that passes through PQ. Any questions? Good. All right, now this one says the coordinates of the points P and Q are -3 and 4, and 1 and 7 respectively. So what respectively mean is the same order that they gave the points here is the same order that they gave the coordinates. So they gave P first. So that means that means that when they give the coordinates, the first coordinate that they give is going to be P. And then they gave Q second. They gave Q second. So the second set of coordinates are going to be for Q. But understand?
Yes,
That's
miss.
what they mean by respectively, right? So P and Q are that and that respectively. So it's to calculate the length of the line segment PQ. All right. So the line segment, the formula for that, the length of the line segment, that part of the line, formula would be the root of y2, remember this, y2 minus y1 squared plus x2 minus x1 squared. All right. So we know what the x's and the y's are. If not, we can just go ahead. The first one is going to be an x. So that's x1, y1. So this would be x2, and this is y2. So y2 minus y1 is 7 minus 4. 7 minus 4 squared plus x2 is 1 minus 3 all squared, right? 7 minus 4 is 3. 3 squared plus 1 minus 3, so that's 1 plus 3, that's 4 squared. That gives you 3 and 3. 3 squared is 9, plus 4 squared is 16. So you now have, I think that's 25.
25.
On square root sign. And the root of 25 would give you 5 units. Questions? Any questions? No? Right, so we can move on to the last one. A straight line passes through the point T, and it gives you the coordinate 5 and 1. And this same line has a gradient of 3/5. Determine the equation of the line. So like before, you have a line, and this line is running on the coordinate, and they just gave you information for 1 point, right? But what you do know is that don't matter what the point is on the line, because the point will be from the same line, the gradient will be the same, and the y-intercept will be the same. So let's go ahead and find the equation of this line. So we have, let's start with information that we do have. We have an x and we have a y value. So this is our x value here, and this is a y value. And we have a gradient here, which is m. So if we're looking at the equation of the line, which is y equals to m x plus c, we see that we already have a y value, right? So that's in our coordinates. We have an m value because we have our gradient. We have an x value in our coordinates, so we only need to find c to give our answer, right? So let's go ahead and substitute what we do have in the equation and then solve the equation for c. So y is 1, m is 3/5, x is 5 plus c. Now we need to work out 3/5 times 5. So I'm just going to go sidebar here just for your benefit. Just go sidebar 3/5 times 5/1. You can decide to go ahead and work across, which is 15 over 5 times 1 is 5, which gives you 3, or you can say 3/5 times 5 over 1, you can cancel 3 over 1. Either way, the answer is 3 plus C. Then you have 1 minus 3, because you're carrying this over the equal sign, equals to C. 1 minus 3 gives you minus 2 equals to C. So you now have your C value. So all that's left to do is to write the equation of the line. All right, so the equation of our line now would be y equals to m, which is 3 over 5 x plus negative 2. Or you could just say y equals to 3 over 5 x minus 2. That would be your answer. Either of these. Well, not necessarily either. This one would be the more appropriate one, unless you're going to put this in a bracket right there. But that would be the most appropriate one. All right. So that is that for that last question. Any questions on what we've done so far? All right, no question. So that is it for our class.